Okay, ma'am.
So the question was, let me take the question quickly, which I have taken yesterday, but I told you that I will be explaining it again. So the question says the wheel of a car are of diameter. There is a wheel of a car whose diameter is given as 80 centimeter. All right. How many complete revolution does each wheel make in 10 minutes? So how many revolution each wheel will make in 10 minutes? Just a moment. Yeah. And the information we are having is when the car is traveling at a speed of the car is given at 66 kilometer per hour. Okay. When the speed of the car is given, that means the car is moving 66 kilometer in 1 hour. Okay. That's the meaning of the speed given. We know the diameter of the wheel. So easily we can take out the radius of the wheel, right? That is 80 over 2. That means 40. Centimeter is the radius, right? We have to find how many revolution the car will make in 10 minutes. We know the car completes one revolution, and that is called the circumference of the circle, right? One revolution means circumference. Yes or no?
Yes, ma'am.
We know the rate 2 pi r. 2 pi r is 40, and this is in centimeter. So if we will try to calculate the circumference in meter, we have to divide it by 100. Okay, let's keep 10 in the denominator. Don't cancel it out. So we will be having 8 pi by 10 meter. That means 0.8 meter, right? Let me write it. Just a second. Can you see the screen?
No, ma'am. Yes, ma'am, you can see.
So it's 0.8 pi meter. That means when one revolution is getting completed, the car is covering 0.8 pi meter for covering one complete revolution. So total distance for one revolution is 0.8 pi meter. Okay. What we have to find, how many revolution car will make in 10 minutes. So speed is given as 66 kilometer per hour. Here the time is given in minute. So let's convert our speed in minute only so that we can work with distance. Okay. So the total distance for one complete revolution is 0.8 pi meter. We have to find what is the total distance the car is covering. Okay. According to that total distance, we will be finding the number of revolution. So speed is given as 66 kilometer per hour. We know why it is getting a stop every time. Like in your class only it happens every day. Do you face such problem in other classes also?
No.
Yeah. Am I audible?
Yes, ma'am.
Do you face this type of problem in other classes also?
No, ma'am.
No. I also don't face this type of problem in other classes. I don't know why in this class only I face a lot of problem. And yesterday I have checked my internet connectivity, that was also fine. Still, it's just getting stopped by itself. So I have informed them. I don't know why it is getting stopped. Can you see the screen now?
Yes, ma'am.
So speed we know it's 66 kilometer per hour. Time is given in minute. Here the distance, the circumference we are having in meter. So let's convert it to meter. 66 kilometer means, can I write 66 into 1000 meter? Can I write? 1 kilometer is equals to how many meters? We know 1 kilometer is equals to 1000 meters, right? Do you know that?
Yes, ma'am.
So we will multiply with 1000 to make this kilometer as a meter. Now this per hour is there. This per hour also I want to convert it to minute. So we also know in 1 hour 60 minutes are there, right? You know that, right?
Yes, ma'am.
So divided by 60 I will be writing over here. Because per hour means by hour is there. So that hour I am converting it in minute. Is it okay to both of you? Let's cancel it out. 0 with 0, 6 with 66. That is 11. So we got 110 per minute. That means the car is covering in 1 minute the car covering 1100 meter. We have to find in 10 minutes what is the total. Let me check. Yeah, how many revolution the car will make in 10 minutes. So before moving to the revolution part, we need to find that what is the total distance the car is covering in 10 minutes. Okay. So at first we will be finding what is the total distance the car is covering in 10 minutes. So in 10 minutes, the car will cover 10 into 1100 meter, right? That means 11000 meter. This is the total distance the car is covering in 10 minutes. Do you agree with that?
Yes, ma'am.
Or you can also use the formula that speed is equals to distance by time. So when the speed is 1100 meter per minute, distance we don't know, time is 11,000 meter. Can you see it? So we
Yes, ma'am.
found distance is equals to 11,000 meter. We already know that one revolution means how much distance? One revolution means 0.8 pi distance, right? 0.8 pi meter. Can you see it? 1 revolution means 0.8 pi meter. So how many revolution means 11,000 meter. That's we have to find. It's just like you have to do the division over here. Like 1 pence cost is 20 rupees. And if you are having 1,000 rupees, how many pence you will get? It's like 1 pence cost is 20 rupees. And if you are having 1,000 rupees, then how many pen you can buy with that? So what you will do, 1,000 divided by 20 you will do, right? That means 50 pen you will be able to buy with that, right? Right, Jasleen and Madiha?
Yes, ma'am.
Similarly, 1 revolution means 0.8 pi meter. So if I am covering total distance of 11,000 meter, that means how much revolution? So we will be dividing the bigger number by a smaller number. So we will be dividing 11,000 by 0.8 pi. So 11,000 divided by 0.8 pi, that represents 0.8 pi. Let's see. Pi value is 22 over 7. Let's substitute it over here. So 11,000 divided by 0.8 into 22 by 7. This divided by 7 will come in the new. This 11 with 22, I can cancel it. 11 2 times 22. Let me inform no. Let me take it over here. So we got 11,000 divided by 0.8 pi. That you will do the calculation. 11,000 by 0.8 pi. That means 11,000 into 7. This 22 by 7 from pi. This 7 will come in the numerator. 0.8 into 22 you will be having. When you will cancel it out, when you will do the calculation, you will get the total number of revolution from. Okay. So it will be just a whole number only. You can check it here. 11 2 times 22, 11 1000. That means 8 2 times 16. So we will be having, please do the calculation, 7000 over 1.6. This 1.6 can be written as 16 over 10, right? Can we write 1.6 as 16 over 10?
Yes, ma'am.
That means we can go ahead and we can do the calculation further. So please do it and check what exactly are you getting. Again, this 5 will go in the numerator. So approximately, let me check what you will get. Yeah, we will be getting 4375. That is the total number of revolution. Okay. So let me summarize the whole thing. What we did here, we were having the radius. We know one revolution means circumference. We found the circumference and that data we kept it aside. That one revolution means this much distance. One revolution, this much distance. Now, what is the total distance the car is covering that we have found by speed and time? Okay, the speed and time, we just kept it in one unit and we have found the distance. You can use the distance formula. That is, speed is equals to distance over time. Okay.
Okay, ma'am.
Once you got the total distance, you are already having one revolution means this much distance. Total is this much distance. Once you will do the division, you will get the number of revolution, that is 4375. Got it? Is it clear to both of you?
Yes, ma'am.
Okay, let's move ahead and let's start the next exercise. This was the last question. Today you will be able to today you will be able to give the assessment from this exercise. Let me start the next exercise. So the next exercise is related to sector, segment. First, you need to understand that we have already discussed in the chapter circle. A quick summary I am giving, and then we will be moving with the formulas. So as we know, sector means what? Sector of a circle means what? When we are having radius over here and a radius over here, when two radius will cover a certain region, that's called sector of the circle, right? So this is
Okay,
called
ma'am.
sector. The above one is called major sector. The below one, which I have marked, that is called minor sector. That is major and minor word is clear to both of you. Now, if I am talking about the segment of a circle, so segment means what? When we are drawing a chord in any circle, then this is called segment of the circle. The upper one here also is called the major segment. The lower one is called the minor segment. So this is what the difference between sector of a circle and segment of a circle. Please don't get confused with the sector and the segment. Okay. When segment is says like written in the question, that means we are having a chord and then whatever portion is getting covered, that is the segment. And sector means two radius will come together to make the sector of a circle. Okay. Now the formula to find the area of sector, area of sector of a circle will be theta by 360 into pi r square. As we know, the total area of the circle is pi r square. When we are talking about the sector of the circle, here we are talking about not the total 360 degree. Here we are talking about a specific angle. That means maybe this angle is 60 degree. So that's why by finding the area of the sector, we have to consider the angle. Like how much angle is covered over there. That much area we need to find. So out 60 out of 3 total angle 360, that is the first thing which we will be writing while finding the area of the sector into the area formula of the circle. Okay, just keep it in mind, this formula. We will be using this formula while finding any sector area. Now the length of arc of sector of angle theta is equals to theta by 360. Again the same thing, but we are trying to find the length of arc. Arc means what? The total curve path. Curve path is circumference of the circle. So when we are trying to find the length of arc of a sector, it will be theta by 360 into 2 pi r. 2 pi r is the formula for finding the circumference. Here we want to find the circumference of a specific region. That's why we are taking theta over 360. Okay. Is it clear to both of you, both the formulas?
Yes, ma'am.
Now
Yes,
let's,
ma'am.
yeah. Now let's start with the question. So here the first question says, let me take the question. Okay. Find the area of sector of a circle. I'm drawing the circle only. This circle sector's area we have to find with radius 4 centimeter and angle 30 degree. So here radius is given as a 4 centimeter and the angle covered is 30 degree. Okay. Also find the area of corresponding major sector. So area of major sector also we have to find. Area of this sector also we have to find. Now only I told you the formula to find the area of the sector is theta by 360. That means 30 by 360. Angle theta is 30 degree over here, right?
Yes, ma'am.
Into area means area formula for the circle, that is pi r square. So pi r is already given as 4, that is square. This will give the area of the sector, right? Which you will be able to calculate, right?
Yes, ma'am.
So no, easily you will be able to calculate it, right?
Yes.
Yeah. Now we have to also find the area of the major sector. So there are two ways by which you can find the area of the major sector. One of them is the other angle. If this is 30 degree, can I say the other angle will be 360? Minus 30. that is 330 degree is the rest of the angle. And by applying sectors formula, the area of the sectors formula, we can find that is angle by 360 into pi r square. R is, since we are talking about the same circle, R will be 4 only. And from here we will find the area of the major sector. Or one more method is there. Let me tell you what exactly that method says. That method says that whatever area you have got from here, like let's calculate it. So whatever area you have got from here, suppose from here you got, please do the calculation quickly and tell me what you got from here. 30 by 360 into 4 square, and here pi is also there. Just keep pi as it is. Okay, so 3 by 336 into 4 and pi I am writing as it is. 4 9 times 36, 3 times 9. So we got 4 by 3 pi, right? This is the area of this minor sector. Now what you can do for finding the area of the major sector, you can do total area of the circle, that is pi r square, minus the area of the minor sector, that is 4 by 3 pi. This is another method to find the area of this part. Can you see it? So either you can apply the first method or you can apply the second method. All right. Can you hear me?
Yes, ma'am.
So either you can find the remaining angle and just you can use the sector's area formula to find the remaining area. Or you can do one more thing, that you can find the total circle area. From that, you can cut down this part area. You can take out this pink area. Cut out means to subtract it. From the total circle area, if you will subtract this pink area, then you will be left with the area of the major sector. Got it?
Yes, ma'am.
So the ways are clear.
Yes, ma'am.
Okay, let's move to the next question. Find the area of segment. Now we have to find the area of the segment of the circle. Let me draw the circle. Here we are having AB as segment. What exactly is given in the question? Area of the segment AYB shown in the figure if radius of the circle is 21 centimeter. So radius is given as 21 centimeter. Okay, we have to find the area of the segment. Now only we were discussing what is the difference between segment and what's the like what segment, what sector. So this area only we have to find here. What else is given in the question? Find the area of the segment AYB in the figure if the radius is given. That's it. And one more angle is given over here, that is 120. Okay. This much information we are having. This is 120 degree. So how we will find the area of the segment? Let me tell you. First, we can find the area of the sector. This sector. Okay. Here angle is given as 120. Radius we know already 21 centimeter. And just now we did one problem related to sector of the circle that says given angle theta. Theta is 120 degree over here. So we will be writing 120 by 360 into pi r square. Pi r is 21 centimeter. Okay, this will give the area of the complete sector. But we don't have to find the area of the sector. We have to just find that shaded portion in the first figure. So how we will find that? Now from here I will take the triangle. I will cut down from here the area of the triangle. So here can you see one triangle is there which is an isosceles triangle?
Yes, ma'am.
Okay, this is 21. So if this is an isosceles triangle, from here if you will draw a line, what is the area of the triangle formula? 1 by 2 into base into height, right? What we want to do from total sector, I want to cut down the triangle. I will take it out the triangle, then we will be left with the shaded portion, right? So from the total sectors area, if we will cut down the triangle area, then we will get the segments area. Is that clear to both of you?
Yes, ma'am.
So total sector area, easily we can find. I have written the formula also, that 120 by 360 into pi into 21 square. That is the total sector area. Now what about triangle area? How we will find the triangle area? The triangle area formula is 1 by 2 into base into height. Do we know base of this triangle AB? No.
No.
Do we know height? No. Do we know?
No.
We don't know anything over here. So how we will find the area of this triangle ABO? Base is AB. Height is OD. We don't know AB. We don't know OD. So how can we proceed with the area of this triangle? Here we will be taking the help of trigonometry. How we will be taking the help of trigonometry? Once I have drawn this perpendicular, this height, altitude if I have drawn, and since it's an isosceles triangle, here I can see this will be 90 degree over here. And here I can say this, when I am drawing the perpendicular bisector, it will cut out the angle in two equal parts. So if total angle was 120 degree, it will get cutted into 60 degree, 60 degree. So here angle will get 60 degree. Here angle will get 60 degree. This is only applicable in isosceles triangle. Okay. Or equilateral triangle, not in a scalene triangle. When you are drawing a perpendicular bisector, it will cut the angle and it will also cut the opposite side in two equal part. So AB is getting cutted in two equal part. That means AD is equals to BD. Both are getting same. Even if we don't know any one of them, but that is fine. Both are same and both are, let's say, X. This is X and this is X. All right. Now, if we will focus on this triangle, this is 21, this is 60 degree, this is 90 degree. We have to find OB, OD, and we also have to find AD. Can you tell me which trigonometric ratio will help us? Let me reverse the triangle. Let me take upside down. then you will be able to visualize it properly. So if I am having this triangle, this is 21, this is 60°. Can you see triangle OAD?
Yes, ma'am.
Any trigonometric ratio which will help us to find, let's say, OD at first? OD. OD is what?
Ma'am, can you use
This is
cos
opposite.
60?
This is adjacent. Yeah, cos. So
Cos
we can
60.
say cos will help us. Cos 60°. What is the value of cos 60? Cos 60 is equals to adjacent, that is OD, by hypotenuse, that is 21. That from here we will get OD is equals to 21 cos 60. What is the value of cos 60? 1 by 2 or what?
1 by 2.
Are you sure?
No, ma'am.
You are not sure?
No, ma'am.
Yeah.
1 by 2?
Yeah, it's 1 by 2 only. Like cos is the reverse, like it will go in reverse way with sine. Sine 30 is 1 by 2, right?
Okay, ma'am.
So cos 30, it will be root 3 by 2. Then cos 45, 1 by root 2. Then cos 60, 1 by 2. So here we will be having 1 by 2. So 21 by 2 is what? Let's write it as 21 by 2 for now. So we got OD as a 21 by 2. Is it clear to both of you? With the help of trigonometry, we got OD as a 21 by 2. Why we are finding OD? To find the area of the triangle. Okay. So OD value I am writing here, 21 by 2. Now what is AB value? AB. Not A, yeah, AB. AB we can't find as of now, but with the help of this triangle, we can find AD, right? Can I say sine 60 is equals to opposite, that is AD, over hypotenuse, that is 21? Can I say? Can I say sine 60 is equals to opposite over hypotenuse?
Yes, ma'am.
What is the value of sine 60? Root 3 by 2 into 21, right? That is AD.
Yes.
And I am now just get back to our triangle, not the smaller part of the trigonometric ratio triangle, the total triangle in the actual figure. So the total triangle is triangle AOB, where ADBD both are same. I told you when we are having isosceles triangle and when you are drawing a perpendicular bisector, it will bisect the angle and also bisect the other side. Okay. So we need base AB. Base AB means what? AD plus BD. AD is root 3 by 2 into 21. BD is also root 3 by 2 into 21. So can I say 2 in 2 times root 3 by 2 into 21 we will do. Then we will get total AB. Right?
Yes, ma'am.
And here 1 by 2 is also there. Let me write everything properly now. So this became 2 times root 3 by 2 into 21. Here we are having, according to the formula, 1 by 2. Once we will do this calculation, we will get the area of the triangle. Once we will get the area of the triangle, we will be able to find the area of the segment. Area of the sector minus area of the triangle. Can you see it? Is it clear to both of you?
Yes, ma'am.
Once you will do the subtraction here, yes, calculation will be there. Quite a lot. Few calculation you have to do it. But we will get the area of the segment. So this is how we will get the area of the segment. You just understand the rule. When you will be doing, I have taken the data where the numbers are very not so calculative and quite a difficult calculation I have picked. But when you will be doing the question from your exercise, you will see that everything is getting cutted off. Okay.
Okay, ma'am.
So here we got the area of the sector, area of the triangle. From sector, if we will take out the triangle, we will be left with that shaded part in the first figure. This is how we will find the area of the segment. Just lock it in your mind that whenever we have to find the area of the sector, there is a specific formula which easily can be applied. This sector, that sector, whatever sector, we can, if angle is given, we are done. Just use the formula and find the area of the sector. But whenever we have to find the area of the segment, that means we need to take the area of the sector's help. So sector area, the total area minus the triangle's area. If we will take out triangle, we will be left with the remaining set. Okay. Let's do the next one. So in the previous question, we will be getting, let me tell you, from the sector area, you will be getting 462, a normal number. From the triangle area, you will be getting 400. 441 by 4 root 3. And you can leave your answer over here. Okay. No need to do the further calculation. Here you can do one more step. You can take out common. If anything is common from both the term, from this number and this number, if anything is common, that you can take it out and then you can leave your answer. Or here also you can leave your answer. Is it okay?
Okay, ma'am.
Yeah. So you don't have to worry about that, oh my God, if we will get root 3 by 2, then how we will proceed and how we will do the calculation. No need to worry about that. Just do the basic calculation, whatever is possible for you. And then write it, arrange it and leave the answer. Next one is from the exercise. If I'll be taking the first question, it says, listen to me carefully. Find the area of a sector of a circle, area of the sector of a circle whose radius is given. Let me draw the circle. Radius is given as 6 centimeter and angle is 60. You will be able to do, right? Both of you will be able to find the area of this sector, right?
Yes.
By sector's formula. Next one, I'm leaving this for you. Find the area of the quadrant of a circle whose circumference is given. Find the area of quadrant of a circle. What is the meaning of quadrant of a circle? If I will divide this circle in 4 equal parts, that is called quadrant. This is one of the quadrant. This is another quadrant. This is another quadrant, and this is another quadrant. So if we have to find the area of quadrant of a circle, we can say total area of the circle by 4. If we will do, that will give the area of the quadrant of a circle. How we say? We need the quarter piece of pizza, right? That means this much pizza we need. 1/4 of a pizza we need. Similarly, we have to find the area of the quadrant of a circle. That means you will find the total area of the circle, pi r square, and that you will divide by 4 to get the area of one of the quadrant. Okay? Is it clear? Is it clear, Madiha and Jasleen?
Yes, ma'am.
Yes,
And
ma'am.
here, what is given in the question? The circumference is given. So if circumference is given, suppose circumference is given as a 21. Then from here, you will be using the circumference formula. 2 pi r is equals to 21. From here, you will get the r value. Once you got the r value, you can find the area of the circle. And once you will get the area of the circle, you can divide it by 4 to get the area of quadrant of a circle, right? Is it clear to both of you?
Yes, ma'am.
Let's move to the next one. I'm leaving this 2 for you. The length of minute hand of a clock. There is a clock. Okay, so the length of minute hand suppose this is how the time shows. The length of minute hand of a clock is 14 centimeter. Let me write it. Find the area swept by minute hand in 5 minutes. Okay. So as we know, minute hand complete, like one complete revolution if the minute hand is making, that is in 1 hour, right? Can we say?
Yes.
Do you know that? The minute hand is making one complete revolution in 1 hour. So here, angle swept by the minute hand in 1 hour is 360 degree, we can say, right? So in 1 hour, minute hand covers 360 degree. That means in 60 minutes, 1 hour means what? 60 minutes, it is covering 360 degree. In 1 minute, it will cover. Just a moment. In 1 minute, it will cover 360 by 60. That much degree, right? Yes or no? Are you getting it? 6 degree. Are you getting it, both of you? In 1 hour, it covers 360 degree, right?
Yes, ma'am.
1 hour means what? 60 minute. That means in 60 minute, it is covering 360 degree. So in 1 minute, it's like 60 chocolate cost is 360 rupees. So one chocolate cost will be 360 by 60, right? From there we got 6 degree. So in 1 minute, minute hand is covering 6 degree. Why we found 1 minute? Because we have to calculate for 5 minutes. From 1 we can go to 5 easily. Okay. So in 5 minutes, it will be covering this 6 degree into 5. That means 30 degree. Is it clear so far to both of you? Radius is already given as 14 centimeter. That is the length of the minute hand. So we know the radius is given as 14 centimeter, length of the minute hand. Now area covered by this minute hand, that means area of the sector. Where we know the angle, where we know the radius, we just have to find the area of the sector. Will you be able to find the area of the sector?
Yes, ma'am.
Theta by 360 into pi r square. R we know 14, theta we know 30 degree. We just have to proceed from here. So the question says length of the minute hand is 14 centimeter. Find the area swept by the minute hand in 5 minutes. Okay. We know the minute hand complete one revolution in 1 hour. You can check it in your watch. If you are having clock at your home, you can go over there and you can check it. That minute hand will cover one complete revolution in 1 hour.